Last week, we started with simultaneous linear equations, and we're looking at elimination method before we ended the class. Where we ended was the second example, eliminating a variable y. And I said when we come, we shall look at the other way around when we want to eliminate x also. So we will be continuing with substitution method, but by then the example 3 and the elimination method, we're going to try it so that we can recollect all that we did under elimination method before we build on with the substitution method. So let's quickly pick the example 3, then we use the elimination method. Let's all try it within some 2 minutes so we can quickly proceed. The example 3, 6x plus 5y equals 4 and 3x plus 5y equals 7. Please, those who join in now, I said we are solving the example 3 using elimination method. Let's all try that within 2 minutes and see if we can actually recollect all that we did in our previous meeting before we continue with the substitution method. So we are all trying the example 3 using elimination method.
Sir.
Yes.
Sir,
Yes.
please can you start eliminating with any complement? Either S can start from S or can start from Y.
That's why last week I said, first of all, were you here when we considered the steps that you have to follow? So under the elimination method, I listed some steps for you to follow. That when you want to use elimination method, you first of all have to consider the variable, choose a variable that you want to eliminate. So you are choosing either X or Y. So it depends on you. But look at the variable that you can easily eliminate. Most especially if there's a variable that they have the same coefficient. It is more easier to what? Pay attention to that variable instead. So these are the steps I gave you last week. Sorry, in our previous meeting. That you follow these steps when we are using elimination method to solve simultaneous equations. Enam, are you okay?
Yes, sir.
Yes, perfect.
Said I had 2 for Y.
Okay.
And then X, I had -1.
Beautiful. So for the example 3, okay, this is the example 3. So you could see that the y variable in both equations are having the same coefficient. So it's easier we eliminate the y. So your solution should match with this. Then since the coefficients are the same, then what we do is we subtract one equation from the other. Because they have the same signs, the y variable that we are eliminating are having the same sign, that is positive. So we subtract. Then from there, we are saying that equation 2 minus 1. Someone can choose to do it equation 1 minus 2. They are all the same. So 3x minus 6x will give us negative 3x. 5y minus 5y will give us 0. Then 7 minus 3 will give us 3. Sorry, 7 minus 4 will give us 3. So that gives us minus 3x is equal to 3. Then we divide through by negative 3. Then we're going to get x to be equal to negative 1. X is equal to negative 1. Then from there we substitute x equals negative 1 into any equation. So I have done a substitution into equation 1. So in place of x in equation 1, I'll replace it with negative 1. So that's going to give me 6 times negative 1 plus 5y is equal to 4. Because from equation 1, I have 6x plus 5y is equal to 4. So in place of the x, I'm putting negative 1. That will give me negative 6 plus 5y is equal to 4. Then I make y the subject. That will give me the negative 6 will go to the 4. And when it crosses the equal sign, to be positive. So I will get 5y is equal to 4 plus 6. And 4 plus 6 will give us 10. Then we're going to get 5y is equal to 10. When we divide through by 5, we're going to get 2. So perfect. That's excellent. Y is equal to 2 and x is equal to negative 1. All right. Now we are going to continue with substitution method. Please, is anyone having questions to ask an elimination method?
No, sir.
All right. Let's now continue with substitution method. Substitution method. In this method, a variable is made the subject and then substituted into the other equation. When you have two equations, simultaneous linear equations, and maybe you don't want to use the elimination method, you can use substitution method. So what we are saying in this method is that, first of all, you consider a variable that you want to make a subject from an equation. So if I'm using equation 1 and I want to make as a subject from equation 1, then after making as a subject from equation 1, I have to substitute it into equation 2. No more the equation 1 itself. No more the equation 1 itself. So if I'm using equation 2 and I made x or y the subject from there, that particular equation left, I have to substitute it into equation 1. Let's look at the examples. Example 1. We have x plus y equals 10 and x minus y equals 2. We want to use substitution method. Considering the example 1. What we have here is a solution, and in the solution, I'm making x the subject from equation 1. So you pick an equation first, then you pick a variable you want to make the subject. So I picked equation 1. Now I'm making x the subject from equation 1. So after making x the subject, I'm going to get x is equal to 10 minus y. Because in equation 1, I have x plus y equals 10. So I want x to be alone. So I will transfer the y to the 10, which will be negative there. So here I have x to be equal to 10 minus y. Then, making x the subject from equation 1, I have to go and substitute 10 minus y for x into equation 2. No more equation 1 again. Equation 1 has finished doing its work. So now I'll go and substitute into equation 2. So what we have here, we said since x is made the subject from equation 1, we substitute 10 minus y for x. That means in equation 2, wherever we see x, we are going to replace it with 10 minus y. You are doing the substitution into equation 2. Please, I want you to take note of this. After picking an equation, equation 1 for instance, and we made x the subject, the substitution is going to make into the other equation left. So now x is equal to 10 minus y. That means whenever we see x in equation 2, I will write 10 minus y. So here I have x minus y equals 2. So in place of x, we have 10 minus y. That's eventually going to result in 10 minus y is equal to 2. Then from there, we simplify. So I have 10 minus y equals 2. Y minus y will result in minus 2y. So the equation now becomes 10 minus 2y is equal to 2. Yes. Savannah. Savannah, unmute yourself.
Say,
Yes.
I don't understand how the Y became 2.
You don't understand how.
The Y became 2.
Okay.
Yeah, that was what I understand.
Hold on, don't unmute yourself. Don't mute yourself. Let's go back to the previous slide. Now, did you understand? I said we should substitute x equals 10 minus y into equation 2. Savannah.
Yes.
Okay. Now look at equation 2. Equation 2, we have x minus y equals 2, right?
Yes.
Okay. And in place of x, we are writing what? 10 minus y, isn't it?
Yeah.
We are substituting x equals 10 minus y into equation 2. So whenever I see this one, whenever I see x, I'll put what? 10 minus y, right?
Yes.
So in equation 2 here, look at the equation 2. The x here now is 10 minus y. But I have x minus y. So that will give me 10 minus y being x minus y again. The bracket here at the down here is for x. Do you get it now? Savannah,
Yes.
are you clear now?
Yes, sir. Yes, sir.
Okay, because the 10 minus y is for x, and the minus y, that's the equation 2, is equal to 2. That's why the y becomes 2.
Okay.
Okay,
Thank you.
welcome. So we have 10 minus 2y is equal to 2. Then I have to group like terms from here. So the 10 have to go to where the 2 is. So I have minus 2y is equal to 2 minus 10, because the 10 on the left hand side was positive. So when it crosses the equal sign to become negative. So that will result in minus 2y is equal to minus 8. Then I have to divide through by minus 2 to make y the subject. So that will eventually give us minus 2y divided by minus 2 is equal to minus 8 divided by minus 2. So we're going to get our y to be equal to 4. The y is now 4, but we could remember that we have x to be equal to 10 minus y. And we know the value for y already. So this equation becomes simple for us to find x. But you can choose to go and substitute your y into equation 1 or 2. It is still the same thing. But since we have a simple equation here, x equals 10 minus y, you only substitute the value for y into that to get x. And our y is 4. So we only replace y with 4. So that will give us x is equal to 10 minus 4, then x is equal to 6. Please, any question? Any question? All right. Those who are writing, we will hurry up with the writing and let's continue. Okay. Let's proceed. Example 2. We have 2x plus 3y equals 8 and 5 minus y equals 3. Please, always take note. Look out for the simplest way we can solve a mathematical question. Over here, I can choose to make x and y the subjects from equation 1. Or I can choose to make x or y the subjects from equation 2. But always make sure that you choose a very simple way. If you are doing substitution method and there is a variable that is not having a coefficient of 1, then make that variable the subject. Over here, you could see that in equation 2, the y there is having coefficient of 1. So it's good we make y the subject. Then our equation will become very simple. So always look out for the simplest way you can use to solve the work. Though if you make x the subject for equation 1 or 2, you still get the same thing, but by then it is going to be complex. Unless there's no simple way, then you go to the very option left for you to do so. So please and please, always let's take a critical look at the question, analyze it very well, and consider the simplest way you can solve the problem. Now, I'm making y the subject from equation 2 because when I make it the subject, I'm not going to get any fraction over there. So making y the subject from equation 2, I'm going to get minus y is equal to 3 minus 5x because I'm sending the 5x to the 3 because I want to make y the subject. Then I have to multiply through by -1 or divide through by -1 because the y being the subject must have coefficient of +1. So over here, when I multiply through by -1, I'm going to get y is equal to 5x minus 3. I hope you're all okay up to that point.
Yes, sir.
Okay, that's very good. So since y is made the subject from equation 2, we substitute 5x minus 3 for y into equation 1. So now we are taking equation 1 now because I made a variable the subject from equation 2. So the substitution will be made into equation 1. So please, under no circumstance should you go and substitute into the equation that you make a variable the subject from. If you use equation 1 to make x or y the subject, don't substitute back into the equation 1, but rather the other equation. Okay, so equation 1 is 2x plus 3y is equal to 8. So whenever I see y, I'll write 5x minus 3. So here I have 2x plus 3y, and the y is 5x minus 3. So since it is multiplying something, I have to put into bracket. So I have 2x plus 3 into bracket. 5x minus 3 is equal to 8. Then when I expand the bracket, I'm going to get 2x plus 15x minus 9 is equal to 8. Then when we simplify that further, that will give us 17x minus 9 is equal to 8. So from here, there's a need to group like terms. So in grouping like terms, that is going to give us 17x is equal to 17. Then we divide through by 17. We're going to get x is equal to 1. Now we have x being 1. There's a need we substitute into the equation we formed. So from y equals 5x minus 3, we substitute 1 for x. So we're going to get y is equal to 5 times 1 minus 3. So we're going to get y equals 5 minus 3 and our y is equal to 2. Please, any question?
No, sir.
Yes, Alan.
Sir, please, why did the negative y become positive?
Okay. And okay, I'm back to the previous lecture. Have you seen why we are making y the subject?
Yes, sir.
Okay. Take a critical look at that. You could see that I've sent the 5 to the 3, right? The 5x.
Yes, sir.
And that becomes minus y is equal to 3 minus 5x.
Yes, sir.
Okay. We are making y the subject. We are not making negative y the subject. Is that okay?
Yes, sir.
So to get y, we need to multiply through a negative 1 or divide through by negative 1. It's the same thing. So when I multiply through by negative 1, negative 1 times negative 1 will be y. Is that okay?
Yes, sir.
It's equal to negative 1 times 3 will be negative 3.
Yes, sir.
And then negative 1 times negative 5x will be positive 5x.
Yes, sir.
Do you get it?
Yes, sir.
So I just want to rewrite it nicely. That will give us y equals 5x minus 3. Now the y is positive, 5x is positive, and the 3 is negative.
Thank
Are
you.
you okay?
Yes, sir.
Okay. Okay, let's proceed. If there's no further question. Number 3. Okay. This is the number 3. We want to make we are using substitution method to solve this simultaneous equation. So let's quickly try our hand on that. You choose a variable you want to make the subject from any equation. So let's quickly try our hand on number 3. Example number 3. There's an alternative method that we'll be looking at. By this time, we're going to get fraction. So let's try our hand on it within some 3 minutes. Then let's look at the solution and then the alternative method. Let's hurry up. You all
Sir,
compare. You all compare. And say yes, Mercy.
Sir, I had
Yes.
y to be 2 and x to be -1.
Y2 x -1. You've also
Yes, sir.
tried.
sir,
Yes.
sir,
Yes. Sarah Vumadi.
Sir, sir,
Yes, I can hear you, Sarah.
I had y to be 2 and x to be -1.
Okay, we'll still look at the answer. So they have something to tell me.
yes, sir.
Uh-huh.
Sir, please, I had my x to be -1 and
Okay, let's look at that. Now, I want to make x the subject from equation 1. I want to make x the subject from equation 1. So now pick equation 1, that is the 6x plus 5y is equal to 4. So first of all, I have to send 5y to the 4. Now you're left with 6x being equal to 4 minus 5y. So since we are making x the subject, I have to divide through the whole thing by 6. So that will give me 6x divided by 6 is equal to 4 minus 5y, all divided by 6. Then that will give us x is equal to 4 minus 5y divided by 6. This is our first phase. Who is confused with making x a subject? Okay, let's continue. Now, since we make x a subject from equation
Sir,
1,
sir,
yes, yes.
please go back. I didn't get that one.
Which one?
From making x a subject from 1 was equation 1.
Okay, now look at it. I have 6x plus 5y equals 4, right? Now I want to make x the subject. So first of all, the 5y have to go. So I told you that anytime you're making something the subject, the thing that you will send away first is the one that is the plot adding or subtracting. That is what you consider first. The a term that is adding or subtracting to the term that you're making the subject. Now after that, you consider division. After division, then you consider multiplication. So over here, we consider the addition aspect first. 5y is adding to 6x. So 5y will go first. So that will give us 6x is equal to 4 minus 5y. And are you okay with that part?
Yes, sir.
Okay. Now what we do next is we have to divide the whole thing by 6 because we want to make x the subject. So I'll divide 6x by 6 and divide here 4 minus 5y also by 6. That is what we had here. 6x divided by 6 is equal to 4 minus 5y divided by 6. Are you okay now?
Okay, sir.
So that will give us 6x divided by 6 will give us x. And that will be equal to 4 minus 5y divided by 6. I hope you're okay.
Yes, sir.
Good. So we're saying that since x is made the subject from equation 1, we substitute 4 minus 5y divided by 6 for x into equation 2. That means whenever I see x in equation 2, I'll put 4 minus 5y divided by 6. So we'll go for equation 2. And equation 2 is 3x plus 5y is equal to 7. Then whenever I see x, I'm going to put 4 minus 5y divided by 6. So that will give us 3 into bracket 4 minus 5y divided by 6, bracket closed, plus 5y is equal to 7. So we have substituted 4 minus 5y divided by 6 for x. So now we don't have any x term again. So now our equation is in just one variable, which is y. So from here, the 3 here is multiplying the whole thing. It can divide the 6. So 3 will cancel itself 1 and go to the 6 2 times. So that is what I have here. 4 minus 5y divided by 2. Because the 3 has gone into the 6 2 times. So the 3 is gone. So I'm left with 4 minus 5y divided by 2 plus 5y is equal to 7. I hope you're all okay up to that point. Who is having a confusion so far? Up to where I've ended the explanation.
Me.
Where
Sir,
is your problem?
from where they use the 3 outside, then into bracket 4.
Look at the equation at the top. The equation at the top is 3x plus 5y equals 7. And in the sentence, we say that substitute 4 minus 5y divided by 6 for x. That means whenever I see x, I will put what? 4 minus 5y divided by 6. Because previously, we said x is equal to 4 minus 5y divided by 6. So into equation 2, we are going to replace x with 4 minus 5y divided by 6. And am I okay?
Yes, sir.
That is why we have 3x. And the x is 4 minus 5y divided by 6. So we've replaced the x with 4 minus 5y divided by 6. That is why we have the 4 minus 5y divided by 6 in the bracket there, multiplying the 3. Are you okay now?
Yes, sir.
Okay. So when we proceed, we have 4 minus 5y divided by 2 plus 5y is equal to 7. So we have a fraction in there again. So we pick, and the rest of the whole numbers are having denominator of 1. So you pick the LCM of the denominators. That is 2. And multiply through the whole thing by 2 to do away with the fraction. So that will give us 2 times 4 minus 5y divided by 2, bracket close, plus 2 times 5y is equal to 2 times 7. So the 2 will divide the 2 here, leaving 4 minus 5y plus 2 times 5y is 10y is equal to 14. That is the 2 times 7. So from there, we have 4 minus 5y plus 10y is equal to 14. And there's a need we group like terms here. All the variables will go to one side and all numbers will go to one side. So that will give us an already minus 5y plus 10y. And now what will it give us? Minus 5y plus 10y.
Minus 5y plus 10y. It will give you positive 5.
Positive?
5.
Are you sure?
Mm,
Are you sure it is positive 5?
yes.
So, positive 2.
Hey.
Minus 5y plus 10y will give us what?
It's positive 5.
Look at, I said minus 5y plus 10y will give us what?
Minus 5y.
Plus 10y.
5y.
5y.
Shadrach,
Positive.
be careful, I don't mention your name. Next time, anyone who will do that, I will not take a candle with the person.
Okay, sir.
So, and that will give us 5y.
Yeah.
Then the 4 will go to the 14. So that will give us 14 minus 4.
It's 10. Say.
Yes.
Say 10.
Okay. So we have 5y is equal to 10. So that will give us, we divide both sides by 5. We're going to get y is equal to 2. So from y is equal to 2 here, we substitute from this equation. From here, you could all remember we're saying that let from here, from here, x is equal to 4 minus 5y over 6. And after finding our y, so always when you're using substitution, you've made an equation simple already. That is where you made a variable the subject. So after finding the other variable, just substitute into where you make a variable the subject. Because that has become simple. Rather than going back for equation 1 or 2, it will be a bit complex for you. Though you still get the same thing, but so that you can save time for time's sake. So from here, what we do is when we find a y, we are just going to substitute it into this very equation. Over here. X equals 4 minus 5y divided by 6. Rather than going back for equation 1 or 2. So that is what we have over here. After dividing, after getting y to be equal to 2, I will now substitute it into where we made as the subject before solving over here. That is where we made x the subject. So y equals 2. In place of y over here, I'm going to put 2. Wherever I see y in this equation, I'll put 2. So we say x is equal to 4 minus 5y divided by 6. So I'll get x is equal to 4 minus 5 into bracket 2. divided by 6. Because the 2 here is equal to y. The 2 here is y. So we are substituting 2 for y. So our 2 here is now y. So that will give us x is equal to 4 minus 10. Because minus 5 times 2 will give us minus 10. All divided by 6. And when we simplify the numerator, that is going to give us x to be equal to minus 6 divided by 6. Because 4 minus 6 will give us negative 6 divided by 6. So our x is equal to negative 1. Our x is equal to negative 1. Please, who is having any problem here? Up to this point. All right. If there's no question, there's no confusion.
So,
And then we said what?
no, it's okay. I'll get it.
Okay. Then we're going to continue. Now let's look at the other alternative method. Maybe if you want to avoid a fraction so that you don't make your work complex, there's another method we can use for the substitution method. An alternative method using the substitution method so that we don't make our work complex. Yeah, I think we'll be adding some 10 to 20 minutes to the time so that we can look at the other alternative method. For the previous time, we wasted a bit. So let's look at the alternative method. Okay. The alternative method. I want to make x the subject from equation 1. Someone can choose to make y the subject from equation 2, or y the subject from equation 1, or x the subject from equation 2. So here we are making x the subject from equation 1. Now, after making that, I have 6x plus 5y is equal to 4, and I have 6x is equal to 4 minus y. So we pause here. Now we have the left-hand side to be in terms of x. That is the 6x. And the left-hand side is equal to 4 minus 5y. Now, if you divide through by 6, you are going to get a fraction, which if you are substituting and you are not careful with a slight mistake, you are going to get the whole word wrong. So let's look at the other way around. I want to maintain equation 3 like that without dividing through by 6. So I will go back to equation 2, where we'll be doing the substitution. I've named my new equation now equation 3. Now let's go back to equation 2. So when I go back to equation 2, I have here 3x plus 5y is equal to 7. So already we can make the coefficient of x in equation 2 to be the same as the coefficient of x in equation 3, so that our substitution will become very simple and easy. We have 3x in equation 2, and the coefficient of x there is 3. 6x in equation 3. Now we are using equation 3 and 2 to solve the work now. So I want to make sure that the coefficient of x in equation 2 and equation 3 are the same. And if we want to use this method, you have to be extra careful in such a way that you don't have fraction in it. And in doing that, if I multiply equation 2 by 2, I'm going to get the coefficient of x in equation 2 and 3 to be the same. True or false? Enam.
True.
Enam. Are you okay? Enam, are you confused?
No, sir.
Okay, good. Now, I'll multiply equation 2 by 2. So always you have to think critically that, okay, I want to make the coefficient to be the same. So what do? You could see that if you multiply the whole equation 2 by 2, you are going to get both coefficients in equation 2 and equation 3 to be the same. So when we multiply by 2, that is going to give us 2 times 3x plus 2 times 5y is equal to 2 times 7. And when we simplify that further, we are going to get 6x plus 10y is equal to 14. Now the coefficients are the same. When we go back to equation 3, you could see that I have 6x is equal to 4 minus 5y. So when I come back here, I have to make sure that previously I have 6x. Let me try and write it here. It's equal to 4 minus 5y, right? Okay. So we now substitute into equation 4, 4 minus 5y for 6x. So whenever I see 6x, I'm going to put 4 minus 5y. Because in equation 3, this equation 3 I've written here, 6x is equal to 4 minus 5y. So whenever I see 6x, I'll put 4 minus 5y over there. So over here, I'll substitute the 6x into that. So that will give me 4 minus 5y plus 10y, because 6x here is 4 minus 5y. 6x here is 4 minus 5y. So I have 4 minus 5y here being the 6x plus 10y is equal to 14. Who is confused so far?
That please me.
Where?
Where you multiplied with the 2.
Where I multiply with the 2, you could have done my extension earlier. Over here.
Where did you get a 2?
Oh, Shadrach, that means you were not listening to
Papa.
me. That means you didn't listen to me at all.
Yes, I went to urinate.
You went
I went to urinate.
here. Okay, and that is fine. I said I want to avoid the fraction so that we don't make our work complex. That is an alternative method. So in doing so, after getting here, equation 3 over here, look at where I'm drawing the circle. I have 6x is equal to 4 minus 5y. If I should divide through by 6, I'm going to get a fraction. And we said that in this alternative method, we don't want to do anything involving fraction before substituting. So I will leave it like this. Go back to equation 2, where I will then be substituting into the equation now I'll use for the substitution. I'll go back there. Fine. The coefficient of x in equation 3, where we wanted to make x the subject, and coefficient of x in equation 2, are they the same? No, they're not the same. So we want to make them the same in such a way that I can just substitute equation 3 straightforward into equation 2. So what can we do to make them the same? Coefficient of x in equation 2 and equation 6. Sorry, coefficient of x in equation 2 and in equation 3. It is 3 and 6. How can we make 3 and 6 to be the same? Shadrach.
So you divide them.
And I said we don't want to see fraction. So if I should divide equation 2 by 2, no, if I should divide.
So will you find the LCM?
No, please. Listen to me, what I'm saying. I am saying that I want to make sure that coefficient of x in equation 2 and coefficient of x in equation 3 are the same. But when you are manipulating, we don't want to see fraction. I hope you know what a fraction is.
Yes, sir.
We don't want to see fraction. So how can we do that? I want coefficient of x in equation 2 and equation 3 to be the same. But we don't want to see fraction. That means we cannot divide equation 3 by 2. Is that okay?
Yes, sir.
So how do we make the coefficient in equation 2 and 3 to be the same? Shadrach.
Yes, sir.
You're lost.
Yeah.
All right. Let me assist you. So you could see that when we multiply equation 2, everything in equation 2 by 2, we are going to get coefficient of x here not to be 6. Isn't it?
Yes, sir.
So in equation 2 and equation 3, after multiplying, won't they now be 6x, 6x?
Yes, sir.
Are you okay now?
Yes, sir.
That is why we are multiplying equation 2 by 2, so that we can have everything there to be the same, being coefficient of x.
Okay, sir.
Okay. Then from there, when we simplify, we are going to get 6x plus 10y is equal to 14. Now this is the equation 3 I've written here. I've written equation 3 here. 6x is equal to 4 minus 5y. I hope you can see that.
Yes, sir.
Okay. So now, whatever I see in equation 4, whenever I see 6x, I'll substitute 4 minus 5y.
Yes,
So into
sir.
equation 4, I have 6x here. So in 6x here, I'll put 4 minus 5y instead of the 6x now. I hope you're okay.
Yes, sir.
So that is why we are having 4 minus 5y plus 10y is equal to 14.
Okay, sir.
Okay, let's proceed. So minus 5y plus 10y. Oh, sorry, here's supposed to be minus 5. I want to group like terms here. So we have minus 5y, here is minus 5y. Minus 5y plus 10y is equal to 14 minus 4. So minus 5y plus 10y will give us 5y, which is equal to 10. Then we are going to get 5y divided by 5 is equal to 10 divided by 5. Then our y is equal to 2. Then when we get y to be equal to 2, we then substitute y equals 2 into equation 3. Then when we do the substitution and we simplify further, we are going to get x to be equal to -1. Yes, any question? Any question? Okay, if there's no question, let's all try our hands on example 4. Let's all try our hands on example 4 using substitution method. Using the substitution method. Yes? Francis? Is that what? I can't hear you. Yes, Sarah.
Sir,
Yes.
for example, 4, I had y to be 13 over 15 and
You solved it already. Wow.
x to be 40 over 9.
I was actually giving it to you to have time on it and do it very well. Probably when you meet next time, then we review it. But we will look at it. Yes. I saw someone's hand up. Benedicta.
Sir, please, it was a mistake.
Okay. So just try this example 4. play with it when we meet next week Monday. We're going to take it from there. I wish we could do the graphical method. By then, I will try as much as possible to see how best I can insert the graph. But if you're going to